So we talked about containers, but how can we implement them? Well, enter Docker. Docker is the most popular container environment in the world by far. It's the de facto standard for containers. It's so popular that today when people say container, they usually mean Docker. It was released in 2013 and immediately gained a huge popularity, which just increased since then. So how exactly does Docker works? What is its architecture? You can see here the main three parts of the Docker environment, and let's go through them together. First, the Docker server or daemon. This is a service that runs on the server and responsible for managing the Docker containers. It turns them on or off, it keeps tab of their activity, it builds containers based on images, as we will see in a minute, and it exposes API for management tools. This is the heart of the Docker environment, and without it, nothing will work. Next are the images. Image is the set of definitions and software for a container to run. If you are familiar with virtual machine images, that's the same idea. So, for example, you can have an image for the front end of the HR application and an image of the database of the e-commerce system. Images are the building blocks of the containers. Now, note that images are static files and they don't run. They are the basis for the containers, but they themselves just lie on the disk and waiting to be called. Now, where do we get the images from? For that, we have the container registries. Container registry is basically a collection of images from where you can pull the image you want and either use it as is or customize it to your needs. For example, you can pull an image for a baseline .NET Core application and then customize it by copying into it your specific code components. You then get a new custom image you can use as a basis for the container. Note that container registries can be public. For example, Docker Hub, which is used by many of Docker users for creating baseline images, or private, and then it's accessible only for you or the organization. And then we have the containers themselves. A container is an image that is built and run. The container runs in a sandbox created and managed by the Docker daemon and is a living, breathing instance of the image. The container is a full-blown process and can do whatever it wants, assuming it has permissions. Again, similar to VM, it's a piece of software that runs on the machine, isolated from the host, but can use its resources. And then we have the client. The client, which is a CLI, command line interface, is where you can send instructions to the daemon. This is your gateway to the whole functionality of Docker, and using it, you can pull images, customize them, run the containers, list them, shut them off, check their status, etc. This is where the IT guys or the DevOps guys will spend most of the time when working with Docker. So that is the basic architecture of Docker, and these are the main parts in it. Now, we said that one of the core capabilities of Docker is customizing images. The ability to pull an image from a repository and then add resources to it is one of the major success factors of Docker, and this customization is done using Dockerfile. So Dockerfile is a file that contains instructions for building custom images. It can instruct the Docker daemon to copy files, run commands, change working directory, and more. Docker files are usually quite small because there are so many baseline images to begin from, and the customization required is not that big. Here is an example of such file. As you can see, it's quite easy to understand what's going on. The file instructs Docker to copy some files, then run npm install, set environment variable, and copy some more files. This is a classic example of a Docker file, and most files look quite similar to this one. Now, we said before, Docker is the most popular container platform in the world, and that shows in the great support it has in various platforms. First, it is supported by all major operating systems, Windows, Linux, and OS X. And more important, it's supported by the major cloud providers. That means you can deploy Docker to the cloud and it simply runs. And even more, the cloud providers have their own container registry you can use for your images. Amazon has ECR, Elastic Container Registry, and Azure has ACR, Azure Container Registry. And that makes Docker even more attractive. Using it means you can develop on your own development machine and then simply package the code in Docker, push it to the cloud, and it will just run. And this is another reason to use Docker and another reason why it became so popular.